Let us look at proposition number 19 and 20 of works of Archimedes, specifically from on conoids and spheroids. The proposition says, given a segment cut off by a plane from a paraboloid or hyperboloid of revolution, or a segment of a spheroid less than half the spheroid, also cut off by a plane, it is possible to inscribe in the segment one solid figure and to circumscribe about it another solid figure, each made up of cylinders or first-off cylinders of equal height, and such that the circumscribed figure exceeds the inscribed figure by a volume less than that of any given solid. So basically, we have to first of all cut off this spheroid by a plane. So we have cut this spheroid by a plane. Now around this segment of the spheroid, we have to circumscribe and inscribe a solid figure made up of first-off cylinders of equal height, such that the difference between them is less than any volume of a given solid. So how do we start off? Let's take the center of the spheroid and let's draw a plane through the axis of this spheroid. And the intersection of this spheroid and this plane will be a conic. Now these two planes are intersecting each other. So let's let's draw a line through that intersection. Let this be B and let this be C. Remember, this cutting plane can be in any way, but the cutoff segment should be less than half. Okay. Now let's take the midpoint of BC and let's draw a line through S and D so that it intersects with the conic at A. Now let's get rid of this description. Here also you have an intersection of the cutting plane with the spheroid. Now through B, we draw a line parallel to the axis of the segment of the spheroid. Remember, AD is not the axis of the spheroid. It is the axis of the segment of the spheroid. Then through C, we take a line parallel to the axis, and through A, we draw a tangent parallel to BC. And now we mark these intersections as E and F. Now let's get rid of these lines. Through EAF, we draw a plane parallel to the cutting plane. And if we pass a cylinder through the intersection of the cutting plane with the spheroid, then the plane through EAF, which is parallel to the cutting plane, will cut this cylinder. So these two planes will set up a boundary for the cylinder and for the segment of the spheroid as well. So this is the boundary of this cylinder that is bound by these two plates. Now this cylinder we have to cut it, but we are interested in only the segment of the spheroid only, and specifically the conic. So let's start off. Let's join AD so that we can get rid of this line that we had drawn. Just to keep it clearer, let's remove this cylinder for the moment. We can still visualize the cylinder. Now this AD, remember, is the axis of the segment of the spheroid. It is not the axis of the spheroid. Now AD, we cut it into equal parts. So we cut it at O, then continually keep cutting AD into segments equal to OD. Now, through O, we draw a line parallel to BC. Now, let me get rid of these planes as well here. Comes a little bit difficult to see. And let's get rid of this plane as well. Now, through the next point, we draw a line parallel to BC. Next point, next, and next. Now, we take the intersection points of these parallel lines with the conic. Just observe carefully. I'll keep marking the intersection points. And now, through these intersection points of these parallel lines with the conic, we draw lines parallel to BE. Now let's zoom in a little bit. I have marked this point of intersection between the line BC and this line which is parallel to BE. The intersection of BE with this line. So I'll just keep marking the points of intersection. So here you will notice this point is outside this conic and this point is inside, outside, inside. Lines are distracting. So let's remove these lines now. Now observe carefully which points I join. So this point is outside this conic and this point is inside. These 2 points I'm joining. And now let's join these points. Okay. So what have we achieved? Instead of focusing on the segment of the spheroid itself, we took the conic and we have cut this conic into smaller slices. Yes. And we have rectangles which circumscribes this conic and one which inscribes the conic. Now, through O, we draw a plane, or rather, through this line which is parallel to BC, we draw a plane parallel to the cutting plane. And we take the intersection of this plane with the spheroid. Then we draw a plane through the next point, parallel to the cutting plane, and draw the intersection. Plane, intersect, plane, intersect, plane, intersect. Okay. Now let me remove these planes so that you can see. So here you will notice this is the overall cylinder. You notice these circles and ellipses that we have as part of each slice. We can form a cylinder and we can form a cylinder towards A. Towards A it is green and towards D it is purple. So if you want to see it much more clearly, let's get rid of this spheroid itself. I'll bring it back. You'll be able to see it much more clear. Now similarly, here we have a cylinder. Downwards, this is upwards. Downwards, upwards. Downwards, upwards. Downwards, and finally, if I tilt it, you will see that PG is a circumscribed figure. PH is a inscribed figure. They are both equal because they have the same base and they have the same heights. Similarly, QI is equal to QK. Similarly, this is equal to this. This is equal to this. This is equal to this. But the last slice has no equivalent inscribed figure. So that means the circumscribed figure minus the inscribed figure is equal to the figure or rather the frusta of cylinder whose height is OD. So we have found, or rather we have circumscribed and inscribed solid figures around a segment of a spheroid such that the difference between them is equal to the volume of the cylinder whose height is OD. And let's say this volume was less than the volume that was given to us. But suppose that volume is much lesser. Then in that case, what do? We reduce the height of OD and we basically cut into two much more smaller pieces. So that when OD becomes smaller, we have more number of slices, circumscribed figure and inscribed figure that get closer to each other, and the difference between them will also reduce. In which case, again, it will be less than the given volume. That is proposition number 19 and 20 of works of Archimedes, specifically from on conoids and spheroids. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.